Hey guys, it's Miss Scott, even though you can't see me, coming to you from right behind this textbook, here to talk to you today about bonding, how to identify different types of bonds using our friend the periodic table, who's the star of our show today. Alright, so just a quick reminder or a quick question, why do atoms bond in the first place? When they bond, they join other atoms. Why do they do that? The answer's simple. Atoms bond together to become stable. So when we talked about ions, we know that most atoms aren't stable in their natural state. The only ones that are the noble gases, which are down here in this last column, because their outer shells, their valence shells, are full. And we refer to this as the octet rule. So to kind of simplify it, the octet rule, every atom wants to have 8 valence electrons. That's our magic number. So this particular one only has 5 that I drew in. So in order for it to become stable, I would have to add 3 more. That would be a happy atom. So how does it do that? There's 2 ways it can do that. It can either form an ionic bond, and an ionic bond is a bond between a metal and a nonmetal. And in this bond, electrons are transferred. So somebody loses an electron, somebody gains it. All right, to give you an idea of what that looks like, I have sodium chloride as our example. So Na, which is over here in this first column, has 1 valence electron. We know that because of the number right here. Chlorine, Cl, is way over here. It's a nonmetal. It's a halogen, and it's got 7 electrons in that group 7a. That's what that means. So I drew a Lewis structure for each of these, showing where the electrons are. Chlorine wants to gain 1. Sodium wants to lose 1. They're a perfect match for each other. So the electron that sodium loses is picked up by chlorine. That forms an ionic bond. This is how we would symbolize it or write it in symbolic form. We put brackets around the symbols, and then a plus for the metal because it lost an electron, so now it's positively charged, and a minus for your nonmetal or your anion. It picked up 1 more negative, giving it that charge. Right? So those are ionic bonds between metals and nonmetals. So a blue and an orange on this table. The other main type of bond we have are the covalent bonds. Covalent bonds form between 2 nonmetals, and in this one the electrons are shared. And so what I tell my kids, remember co, that prefix co means together, like if you're co-workers with somebody, you work together. Covalent, they share electrons. They share electrons together instead of losing them. So here's a picture showing that. Here we have 2 chlorine atoms, so 2 halogens. Each of them has 7 valence electrons. So each one needs 1 more, just needs 1. And if it doesn't have anybody to share it with, what it's going to do is it's going to find another chlorine atom, and they will share that spare electron they each have. So I didn't add any more electrons. I still have 14 total if you want to count there. But this pair is being shared between the 2. That's a covalent bond. All right, so let's practice a little. I'm going to give you, I have some flashcards. I'm going to ask you if they're covalent or ionic, so play along at home. You can pause the video anytime you like. Make sure you have a periodic table in front of you. Or this one will work, that too. All right, so our first one, F2. F2, fluorine is here. I have 2 atoms of fluorine, so fluorine plus fluorine. Both those are nonmetal. That's a covalent bond. All right, CO2. Carbon dioxide, that's a byproduct of respiration, what you breathe out. Find carbon on your table. Right here, C. Oxygen is to the right of that as well. So both nonmetals, so this would be another covalent bond. The electrons are shared. This one's kind of a tricky one. Not really. NaOH. You might be saying, Miss Scott, that has 3 atoms. What are you doing to us? It does. So the oxygen and hydrogen, this is called a hydroxide ion. So hydrogen over here, oxygen over here, they are 2 nonmetals. This part is covalently bonded, and it's called a polyatomic ion. Polyatomic ions are covalently bonded, but they still have a charge overall, which means it still acts like an ion. So basically you can treat this sort of as one atom, one big non-metal sort of conglomerate, So nonmetal. Sodium, I go and I find where sodium is. Sodium's over here in blue, is a metal. So metal, nonmetal, this is ionic. Okay, and let's see, I thought I had one more. No, I do. There we go. This is one you should be familiar with, table salt. NaCl. So just start scanning, find each one. Na is right here. That's in blue. Metal, Cl, halogen, nonmetal. That must be ionic as well. How you can double check to make sure something's ionic or covalent. Ionic bonds always form crystal compounds. So they'll be solids at room temperatures. So things like salt. Covalent compounds can be solid, but you can also find them in liquid form or gaseous form. So here's an example of a covalent compound that you should be very familiar with. H2O, hydrogen, even though it is here on the left side, it's still a nonmetal because it's a gas at room temperature. We only put it over here because of the one valence electron. Oxygen, also a nonmetal. This is water, and we know at room temperature water is a liquid. All right. So if you have any questions about how to tell the bonds using the periodic table, but whether they're ionic or covalent, comment below, and I'll get back to you as soon as I can.